Okay, so for 9-1 similar polygons, we're starting off topic 9, which is all about similarity. And so first we have to understand what a proportion is. So proportion is two ratios that are equal. So you might have seen it as 2 is to 3 as 4 is to 6. 2 is to 3 as 4 is to 6. You notice I already cross multiplied here. The cross multiplication applies because 3 times 4 is 12, and so is 2 times 6. This is going to be a key feature as to how we are solving these problems here today. So now we need our definition of similarity. It's important that we know what a proportion is because that is part of similarity. So two figures that have the same shape but not necessarily the same size are called similar. So remember, if they had the same shape and same size, they were called congruent. Now if they have the same shape but a different size, they're called similar. The symbol for similarity is a squiggle. So very similar to congruent was an equal sign with a squiggle. This is just the squiggle. They're similar. They're not equal. They're similar. Okay? And then corresponding angles are congruent and lengths of corresponding sides are proportional. Okay? So that's what I mean by proportion up here. So let's look at what this means. We have a similarity statement here. It says ABCD is similar to GHIJ. So to look at this, we can see that the angles are congruent, okay? The angles are congruent. A is congruent to G, B is congruent to H, C is congruent to I, D is congruent to J. Corresponding angles are congruent. And lengths of corresponding sides are proportional. So AB is to GH as BC is to HI. And we can continue on that. This is the extended proportion. So I could say CD is to IJ as DA is to JG. That's this part. Now, notice we put the small one on top, the big one on bottom. I like to say it's left one on top, right one on bottom. That can change. It really just depends on the problem. But I like to go based off the similarity statement. This one on top, this one on bottom. So left on top, right on bottom. Left over right. And that's how you find the scale factor. So for example, if, pretend I have those same figures drawn here. Ooh, much worse though. If this was 2 and this was 6 and this is 3 and we don't know what this is. Well, since they're similar, I can say 2 is to 6 as 3 is to what? And then if you're just thinking about this logically, like, oh, 2 times 3, that's 6, 3 times 3, that's 9. Well, that's simple for this one. If it wasn't as simple, we could cross multiply. And we would get 6 times 3 is 18, 2x, and divide x equals 9. Now, you may have been able to do that in your head. Not on all of them, you might not be able to do them in your head. So let's look at some example problems as it highlights in the notes. So first of all, some of the problems will just be identifying what parts are congruent. Remember, the angles are congruent and the sides are proportional. Okay, so we did left over right again. Now, if you look at the posters on Canvas, you'll see a poster that says similarity, angles congruent, sides proportional. And it'll even show a similarity statement. Highly recommend looking at that poster. Looking at this next part, determining similarity. Well, for two things to be similar, we need all the angles congruent and all the sides proportional. So we would have to check, is J congruent to T? Okay, so we got all the angles congruent. Now we got to check if the sides are proportional. This is a very important step in order to determine if they are similar. Let's zoom in on this. And I'm actually going to show, I'm going to show this one. So all the angles are congruent. Now we got to check if sides are proportional. Is 6 to 6, and we're going to say question mark, is that equal to 12 to 6? Well, clearly that's not, but we can finish writing it out. Is that equal to 24 to 16? And is that equal to 24 to 14? We can already see that this isn't going to work out. And is that equal to, oh, that's all of them. So 4 sides, yeah. So we can already see that this isn't going to work out. Those are not equal. Does 1 equal 2? 12 divided by 6 is 2? No, it does not. And that doesn't equal 24 over 16. Well, 4 goes into both of those. 4 and 6, which that can reduce even more. But that doesn't even equal the same thing. And let's see, 2 goes into both those. 12 over 7. None of those are equal. None of those equal each other. Even when I reduce that to 3 halves, that still does not equal each other, which is very important to point out. So these are not similar. Now you're like, but they look similar. They're not. Even though all the angles are congruent, the sides are not proportional, which is extremely important when determining similarity. Okay? Let's look at another example. This one is also very important, okay? This problem tells us that the sides are that the shapes are proportional, similar. It says ABCD is similar to EFGD, which means if they're similar, I know 2 things to be true. The sides are proportional and the angles are congruent. This question isn't about angles, it's about sides. But I know that they're proportional. So I'm trying to find y and x. This question's asking about x. But it's on a smaller one and a bigger one. So I'm going to use sides I know. Well, I don't know these 2. I don't know these 2, but I do know these 2. So I'm going to do the small one over the big one. I'm going to do 6 is to 9 as x is to 7.5. Now I can cross multiply and divide this. So 6 times 7.5, that's 45. 9x, divide by 9, I get x equals 5. Sorry, I ran out of space there. We could do the same thing for y. We could use the same one. 6 is to 9. We don't have to use a different one. 6 is to 9 as y is to 5. 6 is to 9 as y is to 5. So now we do the same thing. 9y equals 30. Divide by 9. We may just have to reduce this fraction 10/3, which is fine because 3 goes into both of those. 30 divided by 3 is 10. 9 divided by 3 is 3. So that is how we can solve for a missing value when we're given those. So this is very important to understand for 9-1. Where'd it go? There it is. Similar polygons. That's the general idea of topic 9, similarity. That's what 9.1 similar polygons is all about.